Hello everyone, this is Dr. Shochinandan Datta, and in this video lecture I'll talk about the few things about the length relationship and the condition factor, as I have prepared both the video on the length relationship and condition factor, but I'll tell about few statistical interference and few statistical result on the length relationship and the condition factor. So here you can see that everything is done, so I'll just explain one by one, so I'll not do any kind of analysis here. So here we have I have the data of length in millimeter and weight in grams. So for the condition factor, as I have earlier told, that this condition factor data we are using basically the centimeter data, so I just converted the length data into the centimeter data, and that centimeter data and the weight in normal gram data is used for this condition factor, three times of condition factor. And so first check the length relationship. For the length relationship, we will converting the weight into the log weight, means logarithm form of this weight, and we also convert the length or millimeter of log length in millimeter, and we will also convert the log length in centimeter. So for this two purposes, so we'll do the whole thing in a single file. So after converting, we'll just check our graph in two graphs. So that is the logarithm form of length relationship, that is log length and log weight. So here we can find you can find the b value and a dash value. Then a dash value you have to convert into a value by converting it in exponential or 10 to the power of this intercept value. And that is the normal length relationship of the nonlinear function of w is equal to a into the power b. So length and weight we are putting, and we are putting the power function, then we can get the a value and b value from this is the normal non-linear function of the length relationship. And as the length of relationship is just a normal linear regression, so we'll do a linear regression function on here. So for this regression we'll use data analysis. So by clicking the data, you will go to the data analysis, and sometimes this data analysis is not appear in your excel here. So you have to make it confirm as make data analysis into your excel tool. So for that you have to go to your file, then go to your option, then you go to your add-in. So you have to add in your data analysis tool pack. So after clicking the add-in will come, and then you have to tick on the data analysis on the add-in. So that add-in means that data analysis will come in your excel. So and then this so here this excel add-in go, and you have to see that your analysis tool pack is tick mark. And from this data analysis tool pack you can also do lots of different kind of statistics analysis, from the descriptive statistics to the t-test, different type of t-test and ANOVA, and one way of ANOVA, two way ANOVA, one sample t-test to two sample t-test paired and paired, then correlation. Then you can do different type of statistics here. So here we'll basically use the regression statistics and regression, and then click OK. And here we'll select the y range. Y range is it's already selected. So y range is your log weight, and x range is your x range is your log length. So it's your log length. So this is it's selected log length. And after selecting this log length and log weight, you just click on the label, as we we selected the label log L and log L and log W. And after that you just check your output value in clicking on this anywhere where you want your output result, and then you just put on the click, and after clicking, so you will get this Excel output of this regression statistics, and from this regression statistics you can also estimate different parameters, and you can also check whether your this length relationship regression is significant or not. And from here you can get your R square value, multiple R square, adjusted R square, and you also check your regression is highly significant. It's very it's close to zero. It's zero. So as statistically we can check that whether it's 95% significant level or not. So p value will check the p value, so significant f value or p value, and that p value is less than 0.05. If it is less than 0.05, then it's significant, and if it is greater than 0.05, then it is not significant. So here you can get your coefficient, means that your intercept and slope, and you can check that your intercept is means that is the your b value is 3.17 as the same of your the graph or value, and your intercept that is the same value intercept, and this is the slope, and from this intercept and slope you can also calculate your a by converting the a dash into exponential or 10 to the power. So here you can calculate your a and b. Now the thing is that we are getting our b value is 3.17, so it is in general theory it is an positive allometric, and but whether your b value is significant or not, so that's why you have to check your b value whether it is significant or not. So that's why we put a statistical hypothesis. The hypothesis says that, null hypothesis says that b is equal to 3, means that is isometric growth, and alternative hypothesis is b not is equal to 3, so that is allometric growth. It could be positive or negative, greater than 3 and less than 3, that doesn't matter. So we have to check whether your growth is isometric or growth is allometric. So that is our goal. So for that we have to do a t-test of our b value. So for that t-test of b value, so the equation is t of b or t of a, means t-test of this b value is equal to b minus 3. So b is the b value of the lethal relationship, b minus 3 by sb. Sb is the error of your intercept. So your b values error, standard error is 0.0298. So that error, so t-test is equal to b minus 3 by your error. So from here you can calculate your t-test normally. So the t-test t value is 5.89. Then you have to check whether it is significant or not. So that's why you have to calculate your p value, and as I earlier told you that p value is equal to, if it is greater than 0.05, then it is not significant. Then you accept your null hypothesis, and if it is less than 0.05, then you accept your alternative hypothesis. So here the p value, for the p value you have to check the t-test p value. So that is a normal function of the Excel. So t-dist, and then you have to put your observed t value, and then you have to put your this degrees of freedom. Here degrees of freedom of residual is 367, and then you have to put your whether it is t-tail or two-tail or one-tail. So it is a normal two-tail, means so two-tail t-test, and then you got your p values. Here the p value is 8.56 and e to the power 09, means it's 0.00000 856. So it's close to 0, means it's an highly significant, means it is get less than 0.05, means 95% confidence level or 95% significant, that your p value is, means your alternative hypothesis is accepted. So here you can check, yes, your b value is allometric growth. So statistically it is proved. So that is required some time to calculate the length or relationship. You also do some statistical analysis also. So that from this way you can calculate your significance of your b value. Now check for the confidence level. Here you can also, one thing important, that is the confidence level, means upper or 95% confidence level of your b value. So b value is ranging 95% confidence level. It's range from 3.11 to 3.23, means 95% confident that your b value is lies in between these two value. So here it is 3.17. And now we'll talk about the condition factor. So here we talk about the three types of condition factor, and three type condition factor we basically calculated from the length weight data, and we are considering the length data in centimeter. So for that reason I have converting the millimeter into centimeter, and that centimeter data used to calculate the length weight relationship, means calculate it used to this condition factor. So in Fulton and modified condition factor, the a value is not required, but in relative condition factor your a value is required. So in the equation is a was there. So for that you have to don't take the a value of the millimeter, because in millimeter the intercept is different, and if you take the centimeter the intercept is different. So for that you have to convert your length centimeter and length and weight. So again you just do length in centimeter, and you just take the weight in gram, and you just do the same analysis and make it a power function. Okay, now you can get your a value from here. So that a value is your for your, so it's 0.0055, so it's a 0.0055. so that is we are converting that thing into 10 to the power of this log form. So it's okay. So 0.55, so that a value we are considering for the relative condition factor. Okay, so then your relative condition factor means mean. So mean of this Fulton condition factor, modified condition factor, and relative condition factors are here, and mean and maximum value are minimum and maximum values are here also. So that's all about the few important things of about the linear relationship and the condition factor. So that statistics is also required sometime to signify whether you're, and here you can also check lots of statistic analysis, you can also check lots of statistics of this condition factor also, and then we'll check later on. And so this all about the few modified form of or few important information about the length of relationship and the condition factor. Thank you.